Well, what defines the cutting edge of technology? For over 80 years, the answer has often been found screaming through the sky at supersonic speeds. The fighter jet is more than just a weapon, it is a concentration of a nation's most advanced scientific and engineering prowess. From the raw, brutal power of the first jet engines to the almost magical invisibility of modern stealth aircraft, the evolution of these machines tells a story of human ingenuity, geopolitical competition, and the relentless pursuit of an edge. The story of the fighter jet begins not with a triumphant leap but with a desperate gamble in the final chaotic days of World War II. For decades, air combat had been defined by the piston engine and the propeller, a technology that had reached its physical limits. Propellers moving near the speed of sound lose their efficiency dramatically. To go faster, a completely new method of propulsion was needed. The answer was the turbojet engine, a radical invention that inhaled air, compressed it, ignited it with fuel, and blasted it out the back, creating immense thrust based on Newton's third law. This wasn't just an improvement, it was a paradigm shift. The first operational jet fighter to see combat was the German Messerschmitt Me 262. When Allied pilots first encountered it, they were stunned. It was over 100 miles per hour faster than their best propeller-driven fighters, like the P-51 Mustang. It couldn't be caught in a straight line, and its battery of 4 30mm cannons could shred a bomber in a single pass. A glimpse of the future, too late to change the war, but it signaled the end of one era and the birth of another. After the war, the victors scrambled to catch up, using captured German technology and their own research. This led to the first generation of mainstream jet fighters, the American F-86 Sabre and the Soviet MiG-15, which defined air combat over Korea. They bore some prop plane DNA, straight or modestly swept wings, simple cockpits, and gun-based armament. Subsonic but faster and higher than ever, they transformed the energy of the fight. Altitude became a weapon, dive to convert potential energy to kinetic for the attack. With rudimentary avionics and no missiles, combat was visual range and visceral, raw piloting skill ruled. The mid-1950s witnessed a sonic boom across military aviation. The second generation obsessed over one thing above all else: speed. Designers envisioned interceptors racing to kill high-altitude bombers. The afterburner, raw fuel injected into hot exhaust, delivered massive fuel-guzzling thrust to push past Mach 1. Aircraft like the F-104 Starfighter embodied this, tiny wings for low drag, not tight turns. Airborne radar let pilots look beyond their eyes, small dishes painting distant blips, albeit with clutter and altitude limits. Air-to-air missiles like the AIM-9 Sidewinder homed on engine heat, promising clean standoff kills. Supersonic speed, radar, and missiles shifted doctrine. Dogfighting was declared obsolete. The small, light, blisteringly fast MiG-21 became the archetypal interceptor. But early missiles were unreliable, with narrow envelopes. Clouds, sun, or a hard turn often defeated them. When fights went close, purpose-built interceptors, sometimes without guns, were poor dogfighters. The lessons would shape the next generation. The missile-only theory was due for a reality check. Vietnam became a brutal testing ground, and the results were alarming. Sophisticated US jets often tangled with smaller, nimble MiGs. Dogfighting was very much alive. Rules often required visual ID, forcing close fights where interceptors were disadvantaged. The F-4 Phantom II embodies the third generation. Massive, twin-engined, two-seat, born as a Navy interceptor. Powerful, huge payload, and improved radar, but early models lacked an internal gun, a costly omission. Later Phantoms restored a 20mm Vulcan, acknowledging close-in needs. Pulse Doppler radar filtered ground clutter, enabling look-down, shoot-down tracking. The AIM-7 Sparrow brought credible BVR, though requiring target illumination made it tactically demanding. The key shift: multi-role. Fighters like the F-4 Mirage 3 and MiG-23 did air-to-air and air-to-ground efficiently. Lessons: renewed focus on maneuverability. Designers balanced high-speed interception with close combat agility. Third gen was correction and maturation, setting the stage for agility and information dominance. The late 70s and 80s delivered the fourth generation, agile fighters shaped by new thinking. Energy maneuverability theory said fighters must change energy state faster than opponents. Designers prioritized high thrust-to-weight and advanced aerodynamics. The results: F-16 Fighting Falcon and F-15 Eagle, radically different from heavy predecessors. The F-16 used relaxed static stability, intentionally unstable, kept tame by fly-by-wire making thousands of adjustments per second. Cockpits evolved, bubble canopy, side stick, and reclined seat to fight G-forces. The Soviets answered with Su-27 and MiG-29, famed for superlative maneuvers. Cockpits became information hubs, the pilot and information manager. HOTAS kept hands on controls, while HUDs projected critical data onto the forward view. Helmet-mounted sights paired with high off-bore sight missiles let pilots look, lock, and fire without pointing the jet. Dogfight geometry changed. First look, first shot became decisive. Into the 90s and 2000s, AESA radar scanned faster, tracked more targets, and shrugged off jamming. Fighters became network nodes, sharing sensor data with jets, ground stations, and AWACS in real time. A pilot could see targets tracked by others with own radar silent, turning a flight into an integrated sensor weapons team. The fifth generation is defined by stealth, low observability to sensors, not eyes, reduce radar cross-section so detection happens late if at all. Faceted shapes, sealed seams, hidden intakes, and RAM coatings all bend, absorb, or hide returns. F-22 and F-35 keep weapons internally. External stores make radar reflections explode. Internal carriage limits load, but buys access, operating undetected deep in defended airspace. Fifth-gen jets are sensor-rich, AESA radar, 360-degree IRS, advanced EW, and high-speed data links. Unlike fourth-gen, a fusion engine correlates all inputs, AWACS blips, IR signatures, shared radar tracks, into a single, clear picture. Flying mostly passive, a fifth-gen jet can quarterback the fight, directing others while remaining unseen. The trade-off is complexity and cost. Stealth coatings and tolerances demand meticulous upkeep. Small flaws can compromise LO. Balancing revolutionary capability against logistical sustainability is a central challenge for air forces in the fifth-gen era. Even as fifth-gen spreads, great powers are designing sixth-gen NGAD Tempest FCS aimed at a new leap. Core Concept 1, Manned-Unmanned Teaming. A fighter at the center of a networked team controlling autonomous wingmen. These drones extend reach, extra sensors, extra weapons, or decoys to soak up fire. The pilot shifts from stick and rudder to mission commander, orchestrating a complex aerial ballet. Adaptive cycle engines reconfigure airflow in flight, optimizing for range, persistence, and dash speed on demand. Data volumes will dwarf human capacity. AI co-pilots will manage sensors, rank threats, suggest tactics, and handle routine flight. The line blurs into a true human-machine partnership. Connectivity is lifeblood, a resilient combat cloud linking assets across air, ground, sea, and cyberspace. Sensors on one platform can guide weapons from another, hundreds of miles away. With ample power and cooling, directed energy weapons emerge, first for defense against missiles, eventually for offensive speed-of-light strikes, with deep magazines. Sixth Gen is about the intelligence and robustness of the network more than any single airframe. From the simple, gun-armed jets of the Korean War, to the AI-driven networked platforms of tomorrow.